So scientifically, technically, um, multitasking is impossible. Like your brain can only do one thing at a time effectively, like actively. But can't we just like say like multitasking is a thing that you can do? Because I mean, technically, no, you can't. But like the colloquialism, that's what I was looking for. Like colloquially, we can understand that if I'm like cooking and also watching a show, then I'm doing more than one thing at a time. Or if I'm like cooking and like doing my homework, or like you are, I don't, maybe you're on computer typing something up and running a live. I would argue that that's multitasking.
Yeah. I don't know if you know who Destiny is, but he plays video games while debating. I have no
Yeah.
clue how he does that because I've tried
Yeah.
to do the basics of that and I can't understand anything anybody's saying. What this really comes down to is at what point does a task become basically like automatic instead
Mm.
of instead of using a lot of frontal lobe bandwidth, right? Like for
Yeah.
example, like as a musician, I had to I don't know why this thing's out of tune and I can't sing. So, but like what I had to do was learn how to sing and play at the same time. And
Mm.
people, that's extremely difficult to do right away. But like eventually it becomes second nature because you're not thinking about one of those things or maybe none of those things.
Mm.
Like it's really funny like with song lyrics like we can just rattle like you can hear a song you haven't heard in 20 years and you know all the words,
Yeah.
right? It's kind of funny. But the other thing that's kind of weird about that is if you try to start in the middle of a song, you won't know what comes next. Maybe some
Mm.
of you have experienced that before. It's a really weird feeling. You have to go back to the very beginning. And that to me that tells me that you're not thinking about it, that everything's just spilling out because you have this neural network in your brain
Mm.
dedicated to it, but it's dedicated to the whole thing. So it
Yeah.
kind of only works if you activate system one first and then start going.
Mhm. Or it takes like a minute or two to like download where you're like, okay, where song is in the middle. I
Yeah.
have to like update and be like, like where I'm at, where is the song? And then you can sort of continue from there.
Yeah.
But yeah, it definitely takes a lot more time to process.
Yeah. I do this with my students because they ask me so much if they can. I don't know if any of you have ever been around teenagers, but they never don't have AirPods in, and it absolutely drives me crazy.
Mm.
But they want to listen to music while they do their studying and their homework quite often, and I'm against it because your brain isn't paying attention to two different things.
Mhm.
And I I love doing this because it's so funny. I prove this to them by I'll have a volunteer come up to the front of the room and I'll give them a marker for the whiteboard and I'll say, here's what I want you to do. Write the lyrics to the Itsy Bitsy Spider while singing Row, Row, Row Your Boat.
Mhm.
It's impossible. Like they write the wrong word or they like it takes like a minute just to write like 5 words.
Yeah.
Even if you're kind of good at this. And I'm like, guys, your brain can only think about one thing at a time.
Mhm.
You don't think about balancing yourself while you're walking. You can do that with your eyes closed. You're not as good at it, but you can do that with your eyes closed. And that's why we can play sports, you know.
Mhm.
And eventually a guy who's a really great drummer learns how their hands and their feet just stop paying attention to what the other one's doing and they're just like doing the music.
Yeah. That's the note for all musicians. Just do the music. Just
Yeah.
make the music happen.
And somebody said you don't have to think to listen to music. Uh, yeah, but your brain is paying attention to the
Mhm.
music, and you don't realize it. I mean, listen to a song that you know, like, and there are studies that say like it works for classical music, probably because nobody knows how any classical music works and it doesn't have words. That probably helps. But listen
Mhm.
to a song you know, and then read a page of some book that you've never read before. Because in school, that's what we're doing. We're learning new things. Pick up
Mhm.
a book you've never read before, listen to a song you know, read that page, and then, I don't know, ask yourself, what did I just read? I don't think that you're going to get a very good self assessment score on that.
Hmm. That's an interesting thought. It's almost like a path of least resistance thing. It's like where my brain attention will go is the thing that it is most comfortable with. So if you, like you said, you're reading a book you've never read before, you'd be less comfortable, quote unquote, with that than hearing a song that you already know. So it would be harder to pay attention to that. That's interesting. Um,
Yeah.
I had another thing I was going to ask you. Or just on that. Oh yeah, the have you heard of the trick where it's like you tell somebody, "Oh, I'm gonna write down a tool and I'm gonna write down a color, and but first I need you to like organize the months by an alphabetical order." So what you do is you're like, okay, so you then you the person does it. They're like, okay, so April, August, and they go through all of them, and then you're like, then now name a color and name a tool, and most likely it's gonna
Blue
be
wrench.
hammer, blue,
Or
yeah,
red
yeah,
hammer, yeah.
red hammer, yeah,
Yeah,
and
it's
I just
red
think of
elephant too is the other one.
red
Um,
elephant. I've never heard of it.
they
Oh,
just
you
say
say
think of a
animal.
color and an animal, and
Yeah,
almost
okay.
everybody says red or blue elephant.
If you
You
say
can do it with
tool,
cards
elephant for a
too.
tool, you might have more problems than attention.
Yeah, you can do it with cards too, because it's like, well, there's 52 cards. It's like, yeah, except 95% of guesses are going to be Ace of Spades, Queen of Hearts, or Ace of Diamonds.
Yeah,
You know?
it's just
So
yeah that
for whatever
the
reason,
tip of the curve
that's
or
how it works.
whatever on the thing.
If I'm successful, then purple hippo will overtake a red elephant as the most as the most guessed answer. Speaking of
Most
that,
good.
I got a whole box of Spankies if you guys want one.
Yeah, everybody
Check
go
out my
buy
store.
Spanky and make sure you like the live. Um, one more question I have is where do you think superhero powers begin? Where do human limitations end, and where do superhuman feats begin? So like you've got like Hafthor Bjornsson, the mountain from Game of Thrones, was able to lift like a 1,200-pound log and walk it 12 steps, which is a huge feat. He's also a huge dude, and like people have been doing like a lot of stuff, but because he's a huge dude, it's I don't want to say easy for him, but easier than say like a small person. I guess I feel like it's a hard question to answer, but if you're willing to take a have any thought on it. Like
So you're
Usain
saying
Bolt,
Halfthor's not a superhuman, but he seems like what does a trait have to be superhuman?
yeah, because like Usain Bolt can run, is the fastest man
Right.
alive, but is that
You
superhuman
know
speed
what?
or is that like the limits of human speed?
You know
And
what?
where,
So funny enough, there's a YouTube channel that does stuff kind of like this. What are they called? I'll figure out what they're called real quick so I can show you.
mhm.
Okay, the YouTube channel is called.
You can never read too
Oh,
many.
it's called Wired. So they do a lot of videos about like sports stuff
Hmm.
where they have like this video called why it's almost impossible to run the 100 meters in 9 seconds. And
Hmm.
they have a lot of things like this sports geared and they go over like literally the mathematics and the biomechanics of like look, a human muscle just cannot do this and they don't do something stupid like this doesn't say well it's impossible to do it in 1 second,
Hmm.
like
Yeah.
that's just dumb. But so like you could theoretically kind of calculate where that line would be. And there's stuff like really tall in my other book that I'm writing right now I talk about David and Goliath. And I
Hmm.
talk about how like look, Goliath wasn't one translation says he was 10 feet tall or like
Hmm.
just a shade under it. The other one says he was like 6'7", which is possible. But like even if he was like, here's another problem with the story. Even if he was like 7 feet tall, he would make a horrible soldier because the vast majority of people are 7 feet tall.
Yeah.
Their bodies don't work very well, and a longer lever. The movies have gotten pretty good about this lately. When there's a giant figure, you notice how like they move really slowly, but that's because
Hmm.
a long lever requires way more effort to swing and it
Yeah.
moves slower. You can test this yourself. Get a really long PVC pipe, go out in the back and try to swing it as fast as you can.
Or
That pipe
sword.
weighs less than a baseball bat, but
Hmm.
you're going to swing it incredibly slowly,
Yeah.
right? So like with the sport, like even if you were like giant, you wouldn't be able to move very quickly. Now if you were 300 feet tall, then yeah, you literally take one step and the race is done, and that might only take a few seconds, right? But
Yeah.
I don't know. Check out Wired on YouTube and
I
look at
I have
the.
seen their stuff. I've never seen that series, but that's very interesting.
It's like the only stuff of theirs I watch, actually.
Hmm.
All right, I got a
Well,
bunch
good
of other
stuff.
people
Yeah, yeah.
waiting, but thanks for
Good
coming
man.
up.
Have a good rest of your night.
So dogs came from like wolves, right? Evolutionary speaking. Um, and I was going to ask, because of us basically like domesticating them and stuff like that, would you call that like what's the word? Artificial evolution, would you say?
It's called artificial selection. Like there's a term for it. Darwin started his book on the origin of species talking about this. He knew a lot about pigeon domestication, weirdly, but he talked about like livestock and stuff like that. So yeah, it has a name. It's called artificial selection.
Okay, so artificial evolution. So, well, artificial selection. Sorry, artificial
I mean,
selection.
you can call it either one if you want.
Okay, okay.
It's
So,
just that the reason we call it artificial selection is because in the wild, nature, like the environment selects what traits are best. So like if you live in a polar environment, nature is going to select against having black fur versus white fur, for example.
okay. So if we have that type of, and now since we have the ability to kind of like look at genetics and like modify them in a way, how kind of easy would it be to, let's say, take some type of animal, right? And let's say like not jump start, but kind of quicken their evolutionary like steps to make them go to whatever like new whatever new species that they would evolve to, if you get what I'm saying.
Um, how easy would it be through genome at the point we're at right now? It would actually be easier to just do it with breeding rather than genetic editing because the genome is just it's so insanely complicated because what we thought is what we would find is there's a gene for this trait. And what we found is that's not the case with almost anything. There are some things where it works that way, but for the most part, oh my fucking god, Anna, I am blocking you. You're so goddamn fucking annoying. Anyways, there. Now she's gone. The God, I lost my train of thought. Okay, I remember where we're at. I'm just trying to collect my thoughts. So you can change an entire gene, but you have no idea what the cascading effects of that are going to be, right? Because one gene is going to affect huge numbers of different traits. So like you may like be able to find through some sort of study, like we know that this gene very strongly influences height. And it's like, okay, well, we manipulated it. And then it's like, well, okay. We didn't realize this at the time, but now that, and maybe it wasn't even the case at the time, but now that we've changed it for this, it's having major effects on bone density. I just made something up, but like whatever. That's going to happen. So where we exist currently, we'd be best to basically just do that through breeding, I would say. In the future, yeah, who knows? I mean, I think we would need computing power that's vastly more powerful than what we have now to be able to figure out, because of how many variables there are, because of how complicated the genome is. But, theoretically it could be done. Practically, I don't know. If you ask me, it sounds like something that's maybe just kind of out of reach, but who knows?
Okay, that makes sense. And then my second question, and then you can get me off, was that looking at like the genes or of something of like a species, are there any type of, I guess you could say, like precursors of what will be the kind of like, because every time something evolves, there's always like a trade-off to it, right? Where they'll gain this, but then they kind of lose this, right? So like I
I
remember.
wouldn't say there's necessarily always a trade-off. I mean, there probably There probably is, because like at the metabolic level, there's always like, well, now, but it's most of them are probably like unnoticeable.
Oh, okay.
But anyways, go. I didn't really let you ask your entire
Well, I was
questions.
gonna kind of just ask if there are trade-offs, if there's like any type of gene or I guess you could say like, yeah, the genes that we can look at to kind of like guess, you know what I mean? Like, you know how we have in our, let's say in our fossil record that there are, what are they called? Uh, I lost my train of thought, but like in between the evolutionary process, like when we look at what hominoids were before, and then we look at like the in the middle between, and we kind of check like that type of stuff. Is there anything that we can look at to see like the trade offs of like, okay, so they gained this, but they lost this. I may have said a wrong question because I can't really like
You're
articulate it
asking me
well.
if we can predict trade-offs?
Or yeah, or kind of like look back in the past and see what kind of caused it, to
Oh,
say.
I don't think so. I am ignorant about it, but like intuitively, it doesn't seem like that would really be the case. But looking at the fossil record, I mean, we're not looking at the genome when we look at the fossil record. Is kind of the other thing. I mean, we do. We pretty much have the whole Neanderthal genome now, but that was extremely difficult to do, and they've only been extinct for like 40,000 years,
Mhm.
which isn't that big of a time frame, in the grand scheme of things. But life hasn't changed that dramatically over the last 40,000 years. So to look at anything older than that and try to figure out like, well, what were the like evolution or like the genetic trade-offs that were going on, I don't think that's within our grasp. And then as far as like looking at it in the future, I I don't know. I would just what's the word? Refer to what I was saying earlier about the
Mm.
how complicated it is, and how you're probably not going to have any luck predicting.
Okay.
It's like
All
it's
right.
like predicting how many hurricanes there will be next year and where they're going to land.
Okay. All right. Thank you. Thank you.
I'm actually a medical doctor.
Oh, cool.
Yeah. Um,
Can you hold on? Can you look at this? I got this thing.
yeah.
Sorry, what's up?
Nothing. I guess I just wanted to ask, like, what's something that people don't know about being a science teacher that you wish people would know?
About being a science teacher. I guess probably something that people probably don't realize is that you're not real the way it's structurally set up. I mean, a teacher has the leeway to do kind of whatever they
Hmm.
want. At least
Sure.
that's always been my experience. I mean, I know that I'm supposed to teach the standards, and
Yeah.
like I'm given a course, a set of course materials, although not all the time.
Hmm.
But a teacher can kind of do whatever they want. That's one thing. But we don't. The curriculum isn't designed to teach what science is. That doesn't
Yeah.
really exist. It's unfortunate. Science curriculum, getting a secondary science education, is a list of facts. That's really
Mhm.
it.
Yeah. Sure.
Now there are a lot of concentrated efforts to like try to make some changes with that and like some deeper level understandings
Yeah.
and all this, but it's more about like connecting concepts rather than what science actually is.
Hmm.
I've been saying like for years that the most scientific class you can take in high school is probably shop class,
Hmm.
because you're actually like experimenting in a way. Like I maybe it's closer to engineering, but
Yeah.
engineering is closer to science than a science class is,
Hmm.
right? Like you can like in a way you can think of science like an analogy would be like, it's more like taking art history thinking you were going to paint. I took an art history class once. I slept most of the time. We didn't do any art. We just learned
Sure.
about art and the history of it and stuff like that. So I try to make my students, like, we do experiments and stuff like that, and I have them at the beginning of the year read a scientific paper, and they have to find the dependent and independent variables and all that kind of stuff.
Mhm.
But yeah, that's probably something that people don't realize
Sure.
is it's a body of knowledge, not a
Mhm.
whatever. So
What ultimately motivates you to be a science teacher?
for the most part, I just like doing the science and stuff like that so much. I
Mhm.
I do think that what I do is important.
Sure.
If I didn't do the only thing, if I wasn't a teacher, the only other thing I'd want to do is do this, and I have a YouTube channel, but I pretty much just post my live
Mhm.
streams to it. Uh, but the only other thing I would want to do is be an educator, and if I could make as much or a lot more money online doing it, then I'd be happy doing it. But only because I
Sure.
know people are learning,
Mhm.
learning the science, because I think that that is super important. But what makes me want to teach is the security and the benefits from it, first of all. But
Sure.
also, it's fun doing the science. I know that none of my students will be scientists. I've been teaching for 10 years, and I
Sure.
have I have several students that are nurses. I have one student who is I think he just like last year finished his PhD in not physical therapy, but oh god, what is it?
Occupational therapy, maybe.
Something like that. So, something really
Mhm.
close to that. That might be it. Um, and I have one other student who's a geologist. But like I'm
Right.
okay with that because what I'm trying to do is teaching them how to think. And I also do like the other part of it that's really important is like the world we live in now, we wield so much power over like particularly like the environment, but also each other, that if we're not scientifically literate and we don't learn how to actually think properly, then we're going to make decisions that have catastrophic consequences, and we will maybe not necessarily collapse,
Mhm.
but that's usually kind of how I think about it. Earlier, I was talking about like Mao's, like people say communism killed, so many people, blah, blah, blah. It's like, well, no, because like pretty much the vast majority of all the people that died under Mao and under Stalin didn't die because they were rounded up and thrown into Siberia or something like that. That
Mhm.
happened. Like it was horrendous, and that did happen.
Sure.
But the vast majority of them were from harebrained, idiotic ideas that caused wide-scale famines. There was Lysenko in the USSR, and then Mao's idiot ideas about agriculture. Pol Pot,
Mhm.
I don't know. He probably was just a
Probably
mass
did.
murderer,
Yeah.
but
Yeah.
and he was proportionally he was the worst from what I understand. But
Mhm.
yeah,
I see. Um, do you feel like the current trends of like how the US is going, do you think people are becoming less scientifically literate over time than their predecessors, or do you see any
no,
general trends?
I get asked this so much, particularly because I debate the stupidest people in the world.
Yeah, I
I don't know
mean,
if you've ever seen my
some
stuff
of the people
before.
on here, like I literally, I mean, I'm a medical doctor, so I know specifically about health. But I was debating someone the other day that was like a nutritionist, and he was trying to tell me like the Tuskegee experiment where they gave vaccines, and I was like, bro, that experiment was people that that had syphilis that were untreated, and
Yeah, they
then
didn't
they
treat
didn't
them. Yeah.
give them the treatment. Like they're just distorting history completely to like fit their narrative, but they don't even know the basic facts. So
Yeah,
I mean,
very
I
stupid.
would deal with it a lot. I've even gotten to like almost fights with people over like, so
Unfortunate.
yeah.
Anyways, so I get asked this question a lot, and the way I usually respond with this is, we very well might have more people today believing in false things than we
Hmm.
did like 100 years ago. But that's because 100 years ago, people just didn't even have thoughts about
Yeah,
most of the things we know about today. Because the knowledge either wasn't democratized because of lack of literacy and internet, or it was just fields of information that we don't know anything about. So people were more ignorant in the past
of course. Yeah.
than they are today. Now, a lot of that ignorance has been replaced with the wrong information, but your average, idiot today that thinks the Earth is flat, I would say probably knows more scientific facts than some of the smartest people alive 200 years ago did, right?
Sure.
So I I don't know.
It's
It'd be
not by
best
their
maybe to
like
draw a picture of it.
intellect.
We've
It's more like
replaced,
yeah.
yeah, we've replaced. Yes, we've become more polarized, but in the process of that, and I don't even know if that's true. That is how it feels. But even
Mhm.
if we've become more polarized, we've still lifted the bottom floor up by a degree that we can't even fathom.
Sure,
So
sure.
I'm optimistic about it.
Yeah. I mean, on the medicine front, we have a lot of people that have just complete distrust with our system. Of course, we're not perfect, but you know, when people just completely reject the opinions of the experts on the subject and they don't like try to engage with it, it's just super frustrating. So I'm sure you have a lot of people coming on the live and then just have a complete, distrust of science, and I don't know how to combat that. Sometimes I feel like it's my duty as like as a person that knows it to like try to educate people, but like sometimes they go out of their way to try to get under your skin and aggravate you, and it's just hard to even engage with them.
Yeah, I mean, when somebody lives in an alternate reality, there's not much you can do. My tactic is always to, instead of having them list things that aren't true, and then me saying, "Well, here are the true things." I mean, I do that, but what I
Hmm.
try to focus on is, let's figure out why you said what you said, and
Yeah.
then you get dial-up internet sounds out of them, which is hilarious, but also proves a very important point. Or I mean, you can demonstrate to them that they don't even believe what they're saying. Like, for example, I talked to this flat earther once. This is one of the funniest things ever. He said, the Big Bang, it's a theory, meaning it can never be proven. He was the angriest person in the world.
Sugar.
And I was like, no, it is proven, which is why it's a theory. And he was so, you don't know that because you weren't there, which means it can never be proven. And I asked him, do you
Hmm.
think atoms exist? And he said, yes. And I said, okay, you realize that our entire body of knowledge about atoms just comes from observations and experiments. We can't see atoms, and it's called atomic theory, right? And
Yeah.
he literally was like, I said, you believe atoms exist? Yes. Okay, you do realize it's called atomic theory, right? And then he goes, yeah, exactly. It's a theory. And I'm like, but you just said,
Yeah.
I was like, what are you doing? So
Yeah.
that's what I try to, it almost never works because I don't know, I have some interesting ideas about the brain for about why that doesn't work necessarily. It's one of my controversial opinions.
Yeah. It is. It's just a very uphill battle that I just feel like we're gonna have to deal with. As time goes on, there's just gonna be people that get like the loud minority, and then they're gonna like just sway the public, and then it's just important for people that are actually educated on the subject to try to just combat just to combat the misinformation. So yeah.
Yeah.
All right, man. Well, thanks for having me on. Like I really appreciate what you're doing. Obviously like in medicine we use a lot of science, so I've always loved science, and I really love my science teachers, and they kind of inspired me to do what I do. So I'm really grateful for y'all people. So thank you so much.
Oh, you're very welcome.
All right.
What is the chemical process of the consumption of uh, alcohol that causes the physical effects and the I don't know if mental effects is the right word. Maybe yeah, I'll just go with that.
So, what is it that like actually makes you drunk?
Yeah, like what is the process or what causes the like mental or physical effects?
So I'm sure there's a bunch of chemicals that have extremely long names, and I don't know exactly what they are. But basically, the ethanol that's in the alcohol, it gets everywhere in your body because it gets into your bloodstream. So the only thing I really know about it is that it just simply interferes with neurotransmitters. I don't know if it's the rate at which they do it or if ethanol can mimic a neurotransmitter. Like the reason lead is so toxic is because lead chemically is similar to certain like neurotransmitters. So it literally like blocks the gateways that those neurotransmitters move across in our nervous system. So it's kind of like turning off your nervous system in certain ways. Again, I don't know specifically if ethanol or the alcohol or whatever mimics that in a certain way, or if it just like drastically slows it down, or exactly what it does. I mean, I could look into that, but
Ethanol causes blindness, right? That's the chemical like during like the Prohibition era, like where they would be like making their own liquors and moonshine. Like that's the
yeah,
blinding
like
chemical.
there. Well, if you make too much, I mean, if you make it incorrectly, it can be super toxic. I'm not sure if it's the ethanol because that's just what's normally in alcohol that'll get you drunk. But like methanol is really toxic. I know that. I don't know if like doing your own homebrew can accidentally produce too much of that. The US government made their own booze that was intentionally formulated to make people sick to discourage people from drinking during prohibition, but but people want to binge drink no matter what, and so a lot of people died off of that government alcohol. It's
Shout
actually
out
kind
to
of
the
insane.
CIA for that.
Shout out to the CIA or whoever it was. I'm not exactly
It
sure,
was
but
factually the CIA. The CIA sent out spiked batches to
I believe
dissuade.
it. Yeah, I
I
believe it.
mean, unaliving people is kind of an odd way to dissuade, but I mean, it dissuaded at least a couple people.
Okay.
Um,
I googled this really quick. Alcohol affects various neurotransmitters in the brain. Yeah, duh, I knew that. Increases the inhibitory neurotransmitter GABA, gamma aminobutyric acid. So it's well, yeah, alcohol's a depressant. I guess I knew that. So that makes total sense. Um, the clumsiness, frontal lobe, that's where it slows down areas of the brain particularly associated with motor function and inhibitions in the frontal lobe, obviously. It does trigger the release of dopamine. Interesting. I mean, you can become addicted to the stuff. Yeah, that's about all I got on it.
all right, now I have another question that I think might be interesting. Is there a way for a person without using any outside resources to somehow mathematically or like physically prove that the Earth isn't flat? I think the
Oh
Earth is
yeah, it's
round,
really
but
easy to do.
all right,
the
how does one do that?
The easiest way to do it is it's best to kind of draw a picture of it, but well, actually, it might be kind of hard to draw a picture of it. So the easiest thing for me is either the sun or the North Star. Now the sun is kind of hard because it only works on the equinox, but for the North Star, it always works. So if Earth is round and the North Star is extremely far away, that means that no matter where you are, let's just pick a spot on the Earth. No matter where you are on the Earth, your position, you'll look out in the horizon, and this creates like what we call a tangent line. So that's basically like kind of like your horizon. It's a flat level line extending everywhere. A tangent's just a line that intersects a circle like this. Well, the North Star, the angle that creates in the sky is always going to be the same as your latitude if you set the North Pole to 0 instead of 90 degrees. That because that's just the reality of the geometry of how that works with a sphere. That's a little like hard to explain, but like what you can do with that is prove that the Earth isn't flat. Because if Earth is flat, then you just do this really basic trigonometry. You find out, okay, there's the North Star, and here's where I am. So you create a right triangle with where the North Star is and then where you are. Now, what you'll know is the angle from where you are to the North Star, and you'll know the other base angle, which will be 90 degrees, and then you know how far away you are from the North Pole. So you have a base and two known angles. That allows you to calculate how far away the North Star is. Then what you do is you take that math and then say, okay, what if I was in a different location? Pick another place a few thousand miles away, and then predict using the exact same math, what will the angle be? Because now you know the height, and you'll have that 90 degrees, and then you'll know your base, so you can predict that other base angle. And it never works, but it always works if you do this, because the angle it creates with you will always be exactly the same as that line coming in and matching the tangent of the curved line. So there we go.
So much for answering. Have a good one.
So there we go. Oh, you're welcome. I would say I answered 1.5 of your questions, because one, I wasn't super... I kind of guessed, and the other I knew.
Yeah, hello, can you hear me?
I can hear you.
I got a question right now, right? How many
for it.
galaxies are there?
Well, from what we can see, there's an estimated... Last I heard, it's between 200 and 400 billion. I think it's closer to the 400 billion.
400 billion?
I believe. Yeah.
Can you help me comprehend that?
No.
Like, what is it?
No.
Like, what is 400 billion? Like, I cannot imagine what that is. 400 billion?
Okay, that's a good question. I'm sure you could figure this out with like grains of sand, and it wouldn't be a surprisingly huge amount. I would guess that 400 billion grains of sand is probably only a few like 5-gallon pails worth of it. But I mean, sand grains are so crazy, so you can see them, but to like spread them out evenly, that would obviously cover an enormous area, like a I don't know, way bigger
But
than
how do we
a
know there
stadium.
are like 400 billion?
Well, we have figured this out because we take images. Like if you want to look up the Hubble Deep Field, that's what you'd want to Google. And what this is it's a picture of a part of space that looked empty. What they did was they pointed the Hubble telescope for like years. They kept pointing it to the same part of the sky, and that part of the sky is insanely tiny. To give you an idea of how small it is. Do you see my circle, and do you see the box right here?
Yeah, I see it, yeah.
This picture they took, if that's the full moon, the picture they took is only about that big of a chunk of the night sky. It's really incredibly tiny. So, the full moon, sometimes it looks big, but if you were to take an aspirin tablet and hold it all the way out at arm's length, it would totally eclipse the full moon. So the moon is actually really, really quite small. Anyways, I tell you all of that because inside that picture, when they did all this long exposure photography, you can look up the picture and it's insane. Everything in it, except for like two things that kind of look like crosses, because that's glare. Everything in it is an entire galaxy. And there are about 10,000 galaxies in that picture. But here's the thing.
10,000?
Keep in mind, the moon takes up a really tiny part of the night sky, and this is an even tinier part. That little square that they took the picture of is only about 1/37 millionth the night sky. They could take that same picture in 37 million other directions and have no overlap. So you take how many galaxies are in that picture and then extrapolate that how many times we could take that picture, and that's how many galaxies there are. And they've done that more than once, so it's not like they only did it once and just assumed everything else. But
What's
there you go.
the closest galaxy to the Milky Way? Like, what is the closest one?
It kind of depends. There are these two things that Kitty. Hold on, my cat is ripping the leather off of my chair. There are these two galaxies. They're kind of like irregular galaxies, but also not exactly. They're called the Magellanic Clouds. You can only see them in the southern hemisphere, and they're small. They're like, if I'm gonna draw so many pictures today. If the Milky Way is about that big, they're only about this large. But they're really, really close to us. And they contain many, many millions of stars. What's really cool is inside of one of them, there's this thing called the Tarantula Nebula. I'm pretty sure it's the Tarantula Nebula. And that's the, of all the places in the whole universe that we've looked, that's the region that is the most dense with new star formation, which is really cool because it's right next to us. The closest spiral galaxy, like a real galaxy, quote unquote, is Andromeda, and it's 2.5 million light years away. So our galaxy is 250,000 light years across. So this galaxy is about 10 times farther away than our galaxy is wide. What's cool about it is in the night sky, Andromeda is actually huge. It's way bigger than the full moon, but because it's so far away, it's incredibly dim, and you actually can't see any of its light unless you use a telescope.
Another question I have is time travel possible? Like, is it
In a
possible?
way, forward time travel is possible in a weird way. So what we found out is the faster you move through space, the slower you move through time. So if you had an identical twin and your identical twin got in like a rocket ship and just orbited around the Earth at really close to the speed of light for what on Earth what we would time for, I don't know, 10 years. When they came back, depending on how fast they were traveling, they would only have experienced perhaps a few minutes, perhaps a few days of time from their perspective. So your identical twin would be way younger than you are. But going backward, there doesn't really seem to be any viable way that works.
What's the biggest known object in the whole universe? Like, what's the biggest planet or star or black hole?
The biggest black hole, I don't know its name, but it's something like, I don't know, 100 billion times bigger than the sun. I don't know if you guys can hear this really loud noise in the background, but my neighbor is like cutting metal with a reciprocating saw or something, and it's making this unbearably loud noise. You can look up pictures of this, but the black hole itself is many, many times bigger than our entire solar system. And that's much crazier than you think it is, because we think the solar system kind of ends at Pluto, but the solar system is the outer edges of it are something like 1,000 or more times farther out than where Pluto is. It's basically called the Oort cloud. You can look it up, but like the size of this black hole makes absolutely no sense. That's probably the biggest singular thing. Like, I wouldn't call a galaxy a thing, and I wouldn't call a galaxy cluster a thing. Now, we know of tons of those, but that black hole is a singular entity, and so I would call that the biggest thing we know about.
Another question is, what is like dark energy and dark matter? Like, can you explain it? Can you explain what that is?
Sort of. Dark matter is, we don't know what it is, but we can see what it's doing. So when we look at when this was discovered first by a guy named Fritz Zwicky, he was looking at galaxy clusters, I'm pretty sure. And what he noticed is, based on the observable okay, let me describe something slightly different for a second. Did you know that if you spin something fast enough, it destroys itself and it flies apart?
Yeah.
Okay, so we see that kind of thing in space. So there are galaxy clusters that are moving through space, and all of the little galaxies kind of travel together. But based on what we see, they move, and I don't know if they rotate as well. I'm not totally sure, but they shouldn't be sticking together. They're too spread out, and there isn't enough star material visible there to keep them together as they move. Another scientist, Vera Rubin, she actually worked out a lot more of the more sophisticated stuff behind this, but she looked at the rate at which galaxies spin, and what she found was the speed at which galaxies spin is like that thing I was describing earlier. The stars should fly apart, right? Just like if you spin a record too fast, it has to be like an insane speed, it will actually break itself and fly apart. Why aren't galaxies doing that then? Well, we don't know, but there's something that has obvious gravitational pull that's holding those things together. And the funny thing is we can see the effects of it through something called gravitational lensing too. So thanks to Einstein and general relativity, we learned that massive objects actually warp and change space. They don't simply sit in space, they actually manipulate it. So that means that light traveling in a straight line will bend around a massive object. That was first proven experimentally by Arthur Eddington in like 1918, 17, 19, something like that. Anyways, when we take pictures of really far away galaxies, what happens is here's us and here's that galaxy. As that light goes toward us, if there are massive galactic structures between us, it will take that light and bend it. And so then the picture of the galaxy really far away becomes distorted like a funhouse mirror. It's called gravitational lensing. You can see pictures of that too. It's really awesome stuff. What was I going to say? So there's that. For dark energy, for dark matter, that's about it. Dark energy, what we found out is the speed at which the universe is expanding is accelerating, which is very weird. If you throw something up in the air, eventually, like it actually slows down. Eventually, it reaches zero, and then it collapses back. Scientists thought that either the universe's expansion is going to be slowing down because of how much matter there is, and that could actually happen in the future, or it would be like steady, but it turns out that it's accelerating. Now we have no idea why space-time does that, but it does, and so we simply call dark energy is basically the name for the property we observe that space-time, the universe does this.
Can you
And that's about it.
sir, can you explain like how the universe expands? Like how does it work? Like how does it expand?
I don't know.
Like
I
what is
don't
it?
think anybody knows why
When
it
someone
does
says
it or
when someone
how.
says
We just
the
know
cosmos
that it
is
does.
expanding, like what is it expanding into? Like what is it?
Well, so you'd be asking me. I think most physicists or astronomers would probably say that that question just doesn't work, because you'd have to, in order to answer that question, you'd have to say, look, here's the universe, and then here's this other thing that the universe is like expanding into or out into. But that would be that would be assuming that something other than the universe exists, and we don't, scientists don't have the balls to make that claim or the evidence to make that claim. So the universe is probably the only thing we know that exists. So to ask what it expands into just doesn't actually make any sense.
So is there like space or time outside the universe?
Well, we have no idea if there's anything outside the universe. It could be, but we can't claim that. Like it doesn't even seem like a testable idea. So it's kind of useless to science. Sad.
Another question is like this question is like a biological question.
Sure, this will be the last one because I do have other people, but thank
Okay,
you.
okay,
It's been
okay,
cool.
okay. What are humans made from, like, like in biology?
You got to be more specific. What elements?
Yeah, what elements like
96% of you is hydrogen, oxygen, carbon, and nitrogen. Oxygen's the most common, I think. followed by hydrogen, then carbon, then nitrogen. And then the next most common are like iron, chlorine, sulfur, potassium, magnesium. I think there's a little bit of that in there. But yeah, 96% of you is just 4 elements. That's it.